Okay, so our today's day, today start with some revision kind of work. Okay. Uh, oh, I forgot. What is the question number that we have discussed last time? 7, 8, 10. Who can tell?
7.
7. So now question 8. Question 8. Find x if find x if 3x plus 1 the whole cube plus 3x minus 2 the whole cube totally upon 3x plus 1 whole cube minus 3x minus 2 the whole cube is equal to 35 upon 19 is equal to 35 upon 19. Last time we did such question, only the difference is that there we were having the squares. Now we are having cubes. So while removing the square root, we need to consider the plus or minus, but while removing the cube root, we don't. So, and don't open the brackets. That will take great time. We need to attempt by using componendo dividendo. We need to do it by using componendo dividendo. Yes, I am waiting. I shall do some steps in between. By componendo dividendo. We do componendo dividendo like this. Oh, Shreyal got the answer. But Shreyal, it is not plus or minus. So I think you need to check. We are taking square root or cube root. Check it. So we did the componendo dividendo. After that, we need to open the bracket. So we open up the bracket. We have there 3x plus 1 whole cube plus 3x minus 2 whole cube plus 3x plus 1 whole cube minus 3x minus 2 whole cube totally upon 3x plus 1 whole cube plus 3x minus 2 whole cube minus 3x plus 1 whole cube plus 3x minus 2 whole cube is equal to 54 upon 16. I just merely opened the brackets. I didn't do very great thing. So we have twice of 3x plus 1 whole cube upon twice of 3x minus 2 whole cube is equal to 27 upon 8. So 3x plus 1 whole cube upon 3x minus 2 whole cube is equal to 3 upon 2 whole cube. Now we can take the cube root on both sides. Taking cube root, we get 3x plus 1 upon 3x minus 2 is equal to 3 upon 2. And you must note that cube root comes negative when the term is negative. Cube root comes positive when the term is positive. So we do not need to take plus or minus. We do not need to take plus or minus. Okay. So we have here 6x plus 2 is equal to 9x minus 6. 6x plus 2 is equal to 9x minus 6. Then shifting the sides, we get 6x minus 9x is equal to minus 6 minus 2. 6x minus 9x is minus 3x, that is equal to minus 8. So x is minus 8 upon minus 3. And then therefore we have x is equal to 8 upon 3. And that is our final answer. X is equal to 8 upon 3. So this is just like a revision purpose work. Okay. Yes, question 9. Again, that would go like a revision kind of work. Question 9. The ratio of the percentages, the ratio of the present ages of A and B is 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 5:7. 7. 3 years before the age of B. 3 years before the age of B was 6 years more than that of A. More than that of A. Full stop. Find the present age of A. Before you solve, don't write anything on the book. Read the question and tell me what hitch in the question is there. There is a small hitch which is unnecessarily put. That is but obvious. Don't solve the question. I don't want answer. I want a common observation. Shreyal, I asked you, don't want answer. I want common observation. Very precisely, I am asking you. I want the common observation. What is your observation? Because there is very typical thing in the question. We are able to solve, but I want you must able to analyze. To solve is one art. To analyze is another art. And when we want to face the challenges, we must be able to analyze. Okay, we shall read the problem. The ratio of present ages of A and B is 5:7. 3 years before, the age of B was 6 years more than that of A. Find the present age of A. Okay, I didn't write age. Find the present age of A. Okay. Now in this question, when I say that 3 years before, now let me know 3 years before it was 6 years more. So in present, is there any difference? Is it going to change by what years it will be more or less? What is your opinion? Will it remain the same that 6 years more or it will be 9 years more? I don't know. Can you tell? That will remain the same. Because it is said 3 years before the age of B was 6 years more. So today also 6 years more. And after some years also, it remains same, 6 years more. And so it is the same. Okay, so what can we do? Let's write. Solution. The ratio of present ages of A and B is equal to 5:7. Let the common multiple be X. Therefore, present age of A 5x years, present age of B is 7x years. Present age of A is 5x. Present age of B is 7x. Okay. Years both. So we can say that according to given, B is 6 years older than A. B is 6 years older than A. Therefore, 7x minus 5x is equal to 6. B is older than A, that is the difference of their ages would be the same, that is 6. Therefore, we have 2x is equal to 6. So x comes 3. But what we need to find out? We need to find out the present age of A only. We don't need to find out any other thing. Okay. So we can say that therefore, the present age of A, the present age of A is equal to 5 into 3 years, as we have calculated x as 3. So it comes 15 years. So it is unnecessary to calculate their ages 3 years before. It is really unnecessary to calculate their ages 3 years before. We already know what is given. Okay. Going ahead. Question 10. If A upon B is equal to C upon D is equal to E upon F, then show that. Then show that 27 in bracket A plus B bracket closed into in second bracket C plus D bracket closed into in third bracket E plus F bracket closed, that is equal to BDF into in bracket A plus B upon B plus C plus D upon D plus E plus F upon F whole bracket raised to 3. Whole bracket raised to 3. This we need to show that. So our solution goes with given A upon B is equal to C upon D is equal to E upon F. We call it as K. So I say C. So we get E upon F is K. Therefore, E is equal to Fk. C upon D is equal to K. We get C is equal to dk. But D doesn't have any value other than this now. So C remains dk only. And A upon B is equal to K. That implies A is equal to BK. Now take the LHS. And put up the values, simplify. Now it is your turn to make it complete Hmm. We shall put the values of the known things A, C, E. Okay. So 27 into in bracket BK plus B. That is into, not addition. Into DK plus D into FK plus F. So it is 27 into B in bracket K plus 1. I took B common from these all. BK plus B. We can take B common. Then now DK plus D. We can take D common. So that in bracket K plus 1 into Fk plus 1. We can take F common. So there comes K plus 1. Now when we watch carefully, all these operations are multiplications. There is no addition. Okay, addition occurs in the brackets, and that is K plus 1 into K plus 1 into K plus 1. So we get 27 into BDF into K plus 1 whole cube. Say number 1. This is our LHS. Okay. Now compare your answer with this. And how many steps did I take? What reasoning I did? See, yesterday we have seen when we write anything, we must be able to make reasoning for that. How to make reasoning, how to understand the things, that is important. Now go for RHS. Our RHS, BDF into in bracket A plus B upon B plus C plus D upon D plus E plus F upon F whole cube. Before I start, I watch carefully and I found that we want BDF in RHS as it occurred in LHS and which is given already. So only in multiplication with that BDF, we must get 27 and K plus 1 whole cube. At least we get the destination. So now put up the values in RHS and go ahead. Put up the values in RHS. What we know, ACE, ACE. Put up the values and go ahead. Hmm. So BDF remains as it is. Then A is BK. So BK plus B totally upon B, plus C plus D upon D. C is dk. So dk plus D upon D, plus E plus F. E is Fk. So Fk plus F upon F whole cube. Then what can we do? PDF remains as it. Yes, I took the gap because I want that you must think. We take B common from the first in the bracket, then D common from the second term in the bracket, and then F common from the third term in the bracket, and the whole bracket cube remains the same. Then we observe that their BB, DD, FF can be cancelled out. So we have BDF, then in bracket K plus 1, plus K plus 1, plus K plus 1, whole cube. And we say that as BDF not equal to 0. BDF not equal to 0. So we could cancel them. Whenever we cancel out the literal term, we must be able to write, or we must have the reason. Why could we cancel that? Okay. So we have here BDF into in bracket thrice of K plus 1, the whole cube. K plus 1, K plus 1, K plus 1. 3 times addition. K plus 1, K plus 1, K plus 1. 3 times addition. So we have thrice of K plus 1, the whole cube. Now, this can be worked as cube of the bracket. We get BDF into 27 into K plus 1 whole cube. That is what 27 BDF into K plus 1 whole cube, which is equal to LHS. And it completes the proof. That is very, very required thing. Now let's check your work at your own. See what were you doing, where you made a mistake, why that mistake happened, what theoretical aspect you applied, and did you ask that aspect to sir whether it is correct or not. Actually, you need to discuss with me what ideas you have in your mind. Are those mathematical ideas, or they are just like your idea? Okay. Going ahead. Question 11. Question 11. Find two numbers in the ratio of 7:12, so that in the ratio of 7:12, so that the greater exceeds the less by 275. The greater exceeds the less by 275. You have to try at your own. We can say ratio of two numbers 7:12. Let the common multiple be x. Therefore, first number is equal to 7x. Yeah, common multiple be x greater than 0. I just make it greater than 0. So first number is 7x and second number is 12x. So we say that therefore 12x greater than 7x. Therefore, according to given ATG, according to given, I took x as positive number. So 12x is greater than 7x. Then it is said that the greater exceeds the less by 275. So 12x minus 7x is 275. 12x minus 7x is equal to 275. Then the subtraction 12x minus 7x is 5x. Therefore, 5x is equal to 275. Therefore, x is 275 upon 5. So we get x is 55. How simple the question is. What were you doing? Huh? After getting x, there is nothing to work. Because almost we are done. So we say therefore first number is 7x that is 7 into 55, which comes 385. Second number is 12x, that is 12 into 55, which comes 660. So we are just making revision work, and I hope you are understanding what we are doing up. We must not miss the things what we are working. Okay, question 12. I am taking some miscellaneous kind of questions, not necessarily related with the same topic, the same thing, okay, but typical one that we are dealing. If x upon a is equal to y upon b is equal to z upon c, then prove that. Then prove that x square plus a square totally upon x plus a plus y square plus b square totally upon y plus b plus z square plus c square upon z plus c totally equal to numerator first bracket x plus y plus z whole bracket square plus a plus b plus c whole bracket square totally upon x plus y plus z plus a plus b plus c. Wow. Let's read the question. If x upon a is equal to y upon b is equal to z upon c, then prove that x square plus a square over x plus a plus y square plus b square over y plus b plus z square plus c square over z plus c is equal to x plus y plus z the whole square plus a plus b plus c the whole square over x plus y plus z plus a plus b plus c. This we need to prove. Okay, I shall start the thing that what we can do. Solution. X upon a is equal to y upon b is equal to z upon c. I consider it as k. I consider it as k. Then we have therefore z upon c is k implies that z is equal to ck. Y upon b is k implies that y is equal to bk. X upon a is k implies that x is equal to ak. Okay. Now we take LHS. X square plus a square upon x plus a plus y square plus b square upon y plus b plus z square plus c square upon z plus c. Now put up the values of these x, y, z as ak, bk, ck respectively and then simplify. the LHS, and then take RHS. That is basic algebra, elementary algebra, we may call it as. So please go ahead. X is AK. So I shall put AK, X square, that is A square, AK square, plus A square upon AK plus A, plus Y square plus B square, that is B square K square plus B square upon BK plus B, plus Z square. Z square is CK, that is C square K square plus C square upon CK plus C. So we did till here. A square K square, that is X square, plus A square upon AK plus A. Like that, Y square plus B square upon Y plus B is nothing but B square K square plus B square upon BK plus B. And Z square plus C square is nothing but the C square K square plus C square, and upon Z plus C remains CK plus C. So we have here, from numerator, I can take A square common in bracket K square plus 1 upon A common in bracket K plus 1 plus B square K square. From that, I can take B square common, so that in bracket K square plus 1 totally upon B in bracket K plus 1. Plus C square in bracket K square plus 1 upon C in bracket K plus 1. You must observe how I am working up. Hmm. Hmm. Yes, something like what Jit has put. Now here, if you observe, then you can say here A that A1's I like B like C. So we get there as A in bracket K square plus 1 plus B in bracket K square plus 1 plus C in bracket K square plus 1 and totally upon K plus 1, as those A, B, C has been cancelled out. So we get like this. Now from numerator, I can take K square plus 1 common, so that in bracket we get A plus B plus C, A plus B plus C into upon K plus 1. Let's give it as number 1, because no further simplification is possible. And don't consider K square plus 1 and K plus 1 can be cancelled out. No, it is not correct. Okay, if you have done like this, then that there is a great misconception. So please forget that. Okay, so K square plus 1 and K plus 1 can't be simplified. They remain the same. Now we are going to take RHS. Yes, I shall write RHS here on the next slide. X plus Y plus Z the whole square plus a plus b plus c the whole square totally upon x plus y plus z plus a plus b plus c. Now we need to put the values of x, y, z. Our x is ak plus bk plus ck the whole square. Then plus a plus b plus c the whole square as it is totally upon x is ak, y is bk, z is ck plus a plus b plus c plus a plus b plus c. So we have here from the first bracket, we can take k common. Bracket में bracket. K in bracket a plus b plus c and that whole square plus here a plus b plus c whole square totally upon k can be taken common from this in bracket a plus b plus c and plus next is a plus b plus c. Then as we know in laws of indices, ab raised to m is a raised to m into b raised to m. Because of this law, I can make the opening of this bracket that goes k square in bracket a plus b plus c the whole square plus a plus b plus c the whole square totally upon I can take a plus b plus c common so that in second bracket I get k plus 1. Similarly, now from the numerator, I can take a plus b plus c the whole square common. From numerator, we can take a plus b plus c the whole square common. So we get a plus b plus c the whole square into in bracket k square plus 1 and totally upon a plus b plus c into k plus 1. Now, when we observe that a plus b plus c the whole square upon a plus b plus c, which can be simplified by making here a plus b plus c, one power can be reduced. Here we have k square plus 1 totally upon k plus 1. Say number 2 from 1 and 2. Look in 1 and 2. Is the same? Yes. LHS is equal to RHS. And so we finished up the proof. Now, just cross tally. Just cross tally your answer. And where you made mistake, what kind of mistake you have made, either in the laws of indices or putting the value or making the square, or did you open the square, etc., etc. How I work? Such problems require some patience. these problems require some patience. Okay. Chalo, question 11. Question 11. If A, B, C, D are in continued proportion, are in continued proportion, comma. Prove that. Prove that. What we need to prove? First bracket open. A square plus B square plus C square, bracket closed. Into second bracket open. B square plus C square plus D square, bracket closed, is equal to, then in bracket AB plus BC, that is wrong, BC plus CD whole square. This we need to prove. Yes, it's a typical problem, and I'm not expecting immediately, but the K method can help us. Huh? What's K method? Yeah, that we shall first of all see the meaning of A, B, C, D are in continued proportion. Okay. And then we consider K, and so we are going to get some values. Yes. And it is in continued proportion. That given four numbers. A, B, C, D are in continued proportion. That is A upon B equal to B upon C is equal to C upon D is equal to K, suppose. Therefore, C upon D is K, which gives us C is equal to DK. Then B is equal to, or B upon C is equal to K, which gives us B is equal to CK, but C is already DK. So DK into K, we get B is equal to DK square. B is equal to DK square. Then we have A upon B is equal to K, which gives A is equal to BK, but B itself is DK square into K, so A is DK cube. We have the values of A, B, C in terms of D and K. What I said, we have the values of A, B, C in terms of D and K. That is important. In terms of, I said, in terms of D and K. So take LHS. LHS, A square plus B square plus C square into B square plus C square plus D square. Now put up their values. Yes, I am waiting for your responses now. I think you only want to write the answer from screen. Huh? You don't have to run the brain. I think it is not correct. You should understand what is going on from your heart, from your brain, not from my screen. Remember very well. And for that, we require practice. And I am making you practiced. It's okay. You are taking time, no worry. But very few persons are responding. Okay. Just now, follow me. Are you follower? Then follow me. So LHS, A. A is dk cube. Its square. Plus B is dk square. Square plus C is dk. So dk the whole square. And in second bracket, B is dk square. And C is dk plus d square as it is. We shall open the bracket. So we have d square k raised to 6 plus d square k raised to 4 plus d square k square into d square k raised to 4 plus d square k square plus d square. Please check your work. Okay, Tanishka has put something. Ah, nice. I think you just verify your answer. Till here, what I did, what you did, compare it. Hmm. Yes, Anant, one small part you have missed, or otherwise you are right. And Tanishka, I think while removing the common from first, you have missed something. Maybe you made dk cube the whole square as d square k raised to 5. I hope so. You have made that mistake. That is d square k raised to 6. But you might have been written that d square k raised to 5. Just cross verify that. From the first bracket, I can take d square k square common. So d square k square common. Then in bracket k raised to 4 plus k square plus 1. Because we divided by that. Now, Anant, you just pay attention. Where you missed, you will understand. Then in 2, we take d square common. K raised to 4 plus k square plus 1. As those two brackets are multiplied. So we do like this. And now, if you watch carefully, d square k square into d square is d raised to 4k square. And that k raised to 4 plus k square plus 1 the whole square. Let it as number 1. Okay. Now we are taking RHS. RHS is AB plus BC plus CD the whole square. A is DK cube into DK square plus B is DK square into C is DK plus DK into D, the whole square. Now I can do these products. Those are D square K raised to 5 plus D square K cube plus D square K, the whole square. That's what I can take D square K common, so that in bracket K raised to 4 plus K square plus 1 and the whole square, square. Now, as I had, as I had claimed here, this one, A into B whole raised to M is equal to A raised to M into B raised to M. I shall apply this. So we get D raised to 4 into K square in bracket K raised to 4 plus K square plus 1 the whole square, which is nothing but our LHS. You can check. So simple. Nice. Very nice. There is alternate way to solve this problem also. Yes, we are going to deal that work. That is algebraic work. This is also algebra, good algebra, that elementary algebra we are using. And that also the second method also goes the same. So I call it as method 1. And now we are going for method 2. Okay. So we say that given A, B, C, D are in continued proportion. A, B, C, D are in continued proportion. So we have A upon B equal to B upon C is equal to C upon D. Okay. So I have, by cross multiplying, B square is equal to AC or C square is equal to BD and AD is equal to BC. What kind of work? You can check here when I consider first two. A upon B is equal to B upon C, cross multiplying, I get B square is equal to AC. Then A upon B is equal to C upon D, so I get AD is equal to BC as I have got over here. And when I take second and third are equal, then we get C square is equal to BD that we have got. Okay. Now I shall take LHS. Okay. Our LHS is A square plus B square plus C square into B square plus C square plus D square. Good. Now A square, A doesn't have any value over here. So I keep A square as A square plus B square is AC and C square is BD. Okay. But I'm not going to put C square as BD. Why? Because I need to take something common. So I keep c square as it is. And here, what we have? B square, I shall keep B square as it is. C square as BD plus D square. Okay. What is the use of this all? Master, is it useful that you are getting something? Huh? I can't take common. Really? Yes. So if I take C square as BD, even if I can't take anything common. Oh, A square plus B square plus C square. So if I take B square as AC, C square as BD, nothing goes common. Arara. What should I do then? Hmm? Should I quit from method 2? That no, method 2 is not possible. How can I simplify this? Huh? Just a minute, I will be back. Just hold on. You go ahead for thinking. Square. Oh, that is equal to AB plus BC plus CD. AB plus BC plus CD, the whole square. Now, if you watch carefully, here we don't know what is AB. We don't know what is BC. Yes, we know. BC is nothing but AD. You can check here. BC is nothing but AD. Do we know CD? No, we don't know CD. Okay. And then therefore, we can't resemble. I said resemble. Okay. So we need to resemble the things. And without using K method, that has importance. Without using K method, we must be able to go by doing something. Okay, just a minute. Okay. And then therefore I have some idea in my mind. What? That's very weird idea. Very weird idea. This is our to prove that, so I am just rubbing out. I shall make the product of these brackets instead of putting the values now. Literal product? Yes, I can. So we have a square into in bracket B square plus C square plus D square plus B square into in bracket B square plus C square plus D square plus C square in bracket B square plus C square plus D square. Then now opening the brackets. A square into B square, A square B square plus A square C square plus A square D square plus B raised to 4 plus B square C square plus B square D square. I hope you are understanding what is going on. Plus B square C square plus C raised to 4 plus C square D square. Ara baba baba baba. So we have got two terms, total 8 terms or 9 terms. Let's count. Yes, we have got 9 terms. Very nice. Now keeping watch on our RHS. Our RHS is AB plus BC plus CD the whole square. Can you tell me how many terms are there in this expansion? How many terms are there in this expansion? Can you tell me? Can you give me? How many terms are there in this expansion? AB plus BC plus CD or the square of trinomial. My question is, how many terms are there in the expansion of square of a trinomial? Who can answer this question? Forget this for a while. Okay, Raj Lakshmi says 9. Somebody says 6. What is the correct answer? The 6 terms is the correct answer. There are 6 terms. And remember, this is our, where is that? Yes, here is. This is our RHS part. And now I am going to make the adjustment. Okay. So I came to know that I want a square b square. I want the term a square b square. Here it is. I want b square c square. Here it is. I want c square d square. Here it is. So I shall write them as a square b square plus b square c square plus c square d square. And now plus. Okay. Why did I say okay? You will understand it's is soon. As a square c square is actually b square. B square square. So I shall make, and b square is again b square, and these they are closely related. I hope so, because AC is b square. So a square c square is b raised to 4, or b raised to 4 is a square c square. Okay, so I can put b raised to 4 as a square c square. So I get here a square c square plus a square c square. Okay, so I shifted b raised to 4 as a square c square. Now in the same fashion, if you check this, a square d square and b square c square. And watch this. Okay, AD is equal to BC. So if I say there plus b square c square plus b square c square. Oh, why? Because AD is equal to BC. Okay. No worry about that. And then lastly, as we worked on a square c square and b raised to 4, similarly, we are going to work on this, and we get b square d square plus b square d square. So I can clearly write a square b square plus b square c square plus c square d square. My first 3 terms I wrote. Now it would be twice of a square c square plus twice of b square c square plus twice of b square d square. But it doesn't suffice, because we know that the square of our x plus y plus z the whole square is x square plus y square plus z square plus 2xy plus 2xz plus 2yz. Our x is AB. Our x is AB. But here we don't have. But yes, we shall have. How? That I can make it as a square b square as it is plus b square c square as it is. Sorry, b square c square I wrote wrongly. Plus c square d square plus twice of AC into b square. AC into AC. What I said, AC into AC. So that is AC into b square. Similarly, here I can make BC as plus twice of BC into AD, because BC and AD are equal, and plus twice of BD into C square. Oh, I just made the adjustments like this. Okay. Now more algebraic adjustments are required. Means yes, I shall just make some space for me. The algebraic adjustments will go like a square b square plus b square c square plus c square d square plus 2ab into bc, 2ac into b square as 2ab into bc plus 2bc into ad plus now for this 2bd into c square. Bd into c square can be said as 2bc into cd. 2bc into cd. Oh, but bc into ad. Sorry, this I made a mistake. That should be ab into cd. Now you can compare. Now you can compare with our well-known opening of x plus y plus z the whole square, which is x square plus y square plus z square plus 2xy plus 2xz plus 2yz. Now you can check this is x, this is y, this is z, and now you see what is that? That is nothing but AB plus BC plus CD the whole square, which comes RHS. Hence, we completed the proof because of that. Okay. So for today, it is sufficient. We shall see next time. Bye bye.